Welcome to the DIY Honda Garage channel. The DTC P0532 indicates a low voltage condition in the AC pressure sensor circuit of the Honda Civic models from 2016 to 2021. The AC pressure sensor plays a crucial role in monitoring the refrigerant pressure within the AC system. It is typically located on the AC lines near the compressor. This sensor sends information to the Powertrain Control Module, PCM, which regulates the operation of the AC system. When the system encounters a low voltage signal from this sensor, it can indicate potential issues that may affect the AC's performance. Understanding the implications of this code is vital for effective troubleshooting and ensuring a properly functioning AC system. The error described by DTC P0532 is specifically associated with the AC pressure sensor detecting a low voltage condition. The AC pressure sensor is responsible for measuring the refrigerant pressure and transmitting this data to the PCM. It is situated near the AC compressor, typically on the AC lines. When the voltage read from this sensor falls below 0.24 volts, it triggers the DTC P0532. This can impede the AC system's ability to operate efficiently, leading to possible performance issues. Understanding the location of the sensor is crucial for effective troubleshooting, as it can help technicians quickly identify and address the problem. Therefore, a comprehensive analysis of the sensor's output and associated wiring is necessary. Several possible causes can lead to the activation of DTC P0532. The most common reason is a faulty AC pressure sensor, which may not accurately transmit the required voltage to the PCM. Additionally, poor electrical connections, such as loose or corroded terminals, can disrupt the flow of electricity to the sensor, resulting in a low voltage reading. Another factor to consider is an open circuit within the wiring that connects the sensor to the PCM, which can prevent proper signal transmission altogether. Each of these elements must be examined thoroughly to ascertain the root cause of the low voltage signal, ensuring a comprehensive approach to resolving the issue. When DTC P0532 is present, several symptoms may arise, indicating an issue with the AC system. The most prominent symptom is likely failure of the AC system, manifesting as a complete lack of cooling. Additionally, drivers may notice inconsistent cooling performance, where the air conditioning does not maintain desired temperatures, leading to discomfort. Furthermore, the illumination of dashboard warning lights related to the AC system may occur. Recognizing these symptoms is vital for both drivers and technicians, as they can help in promptly addressing the underlying issues triggered by the DTC. Identifying these symptoms can also expedite the troubleshooting process and lead to a more accurate and rapid repair. The first step in troubleshooting DTC P0532 involves verifying the problem through engine diagnostics. Begin by starting the engine and allowing it to idle, ensuring that the AC system is in a functional state. Next, activate the blower switch to facilitate air circulation within the cabin. Then, switch on the AC to engage the system fully. Utilizing the Honda Diagnostic System, HDS, check the parameters displayed for the AC pressure sensor, focusing on whether the voltage reading is below the threshold of 0.24 volts. Evaluating the current conditions against this threshold assists in confirming whether the failure is duplicated, guiding the subsequent steps in the diagnostic process effectively. In the second troubleshooting step, the goal is to further isolate the potential failure area. First, turn the vehicle to the off-lock mode to ensure safety during diagnosis. Next, carefully disconnect the 3P connector of the AC pressure sensor to remove it from the circuit. Once the sensor is disconnected, switch the vehicle to the on mode to enable the diagnostic checks without the sensor influencing the readings. Again, utilize the HDS to observe the parameter values of temperature and pressure signals. The key focus here is whether the voltage remains below the threshold of 0.24 volts, as this result will dictate the next troubleshooting action, helping to pinpoint the source of the issue in the system. The third step involves measuring the voltage between specific test points on the AC pressure sensor circuit to verify its functionality. Begin by ensuring the vehicle is in the on mode, while the AC pressure sensor remains disconnected. Measure the voltage between test point 1 and test point 2, where test point 1 is the AC pressure sensor connector number 1, and test point 2 is number 3. It is critical to observe whether the voltage reading is around 5.0 volts, indicating that the sensor circuit is energized correctly. If the measurement confirms this voltage, it strongly indicates that the AC pressure sensor is faulty and requires replacement. This step is crucial, as replacing a malfunctioning sensor is a necessary action to restore the proper functionality of the AC system. In the fourth troubleshooting step, the objective is to check for continuity in the VCC6 wire, which connects the AC pressure sensor to the PCM. First, switch the vehicle to the off lock mode to ensure safety. Utilizing the HDS, jump the SCS line to initiate diagnostics and wait for more than 1 minute. Following this, disconnect PCM connector E to prevent interference during the continuity test. Now, use a multimeter to check for continuity between test point 1, located at the AC pressure sensor connector number 3, and test point 2 at the PCM connector E number 63. This step will help ascertain whether the VCC6 wire is intact, guiding toward the resolution of the problem. If continuity is confirmed, it indicates that the wiring is functional, prompting further investigation into authorized service information or substitution of the PCM. The final troubleshooting step aims to check for a short in the PD sensor wire connecting the AC pressure sensor to the PCM. Start by turning the vehicle to the off lock mode for safety. Next, jump the SCS line with the HDS and wait for at least 1 minute to prepare the system for the diagnostic test. Following this, disconnect PCM connector A for accurate results. Use a multimeter to assess continuity between test point 1, which is the AC pressure sensor connector number 2, and test point 2 at the body ground. This step is essential for determining whether there is a short circuit in the PD sensor wire. If continuity is confirmed, it suggests a fault exists within that wire, requiring repairs. If there is no continuity, further evaluation of the wiring and component connections is warranted. After completing the necessary repairs, it is pivotal to verify that the DTC P0532 has been resolved successfully. Begin by clearing the DTC from the PCM to reset any stored error codes related to the AC pressure sensor. Following this, test the AC system thoroughly to ensure that it operates correctly, producing desired cooling without any fluctuations or performance issues. Monitoring the AC pressure sensor readings with the HDS will help confirm that the system is functioning within acceptable parameters. Additionally, it's advisable to perform a road test to further ensure that all conditions are optimal and the AC system runs smoothly. This verification process ensures that the issue is completely resolved, providing reassurance for the vehicle owner that their AC system is operating efficiently. Preventive maintenance of the AC system is crucial to avoid the recurrence of DTC P0532 and to keep the air conditioning functioning efficiently. Scheduling regular checks of the AC system will help catch any potential issues before they escalate into major problems. During these inspections, pay special attention to wiring connections, ensuring they are secure and free from corrosion, as these can greatly impact system performance. Additionally, ensuring that the AC pressure sensor is properly calibrated can prevent erroneous readings and unnecessary diagnostic trouble codes. Taking these preventive measures will not only enhance the longevity of the AC system, but also improve overall driving comfort for the vehicle occupants. In conclusion, DTC P0532 highlights a significant issue within the AC pressure sensor circuit that requires immediate attention. Understanding the role of the AC pressure sensor in regulating the air conditioning system is crucial for diagnosing the problem accurately. Systematic troubleshooting is essential to identify either wiring issues or faulty components that might lead to low voltage readings. Taking a methodical approach to each step not only ensures effective resolution of the DTC, but also enhances the reliability of the AC system in the Honda Civic from 2016 to 2021. Following up with preventive maintenance measures can mitigate future problems, solidifying the vehicle's performance and the driver's comfort. Please like and subscribe to the channel. See you next time.